This is step 4 of our workshop where we add the graphical user interface. At this stage, we already have the components for the file system and the RTOS in our project. And we now add the graphics display. The STM device has an on-chip graphic controller with RGB interface. However, the graphic display of the board also has a configuration interface that uses the SPI5 interface. The software pack contains board support with interfaces for most board peripherals, and I just need to select the right components for the runtime environment. So let's start our project and add the graphics components. In the RTE window, I select the board support EMWin LCD interface. This component is the interface to the LCD display of our evaluation board. Then we need a user interface for the display. And therefore, I choose from the graphics component the core. The graphics core needs a display interface configuration where screen size and other parameters are defined. Predefined displays are available under graphics display, and the pack already has a configuration for the STM32 board that I just select. We added now all the relevant graphics components, and these need peripheral interfaces. The driver requirements are listed in the validation output. Again, I may select each component manually, but with Resolve I can choose them automatically. The graphics display appears as an external SDRAM to the microcontroller, and external memory connects via a bus system that is typically configured with the CMSIS system file. The Cube framework provides defines to enable typical configurations. At the C++ tab, I just add these defines. Okay, next I configure the SPI5 interface for the graphics display. The setup for the CMSIS drivers is in the file rte-device.h. I enable SPI5 and change the pin setup to match the schematics. The file GUIconf.c configures the graphics core, which uses a dedicated memory. As the default configuration exceeds the available memory of most systems, we need to change the setting to 4000 TEX, which is sufficient for many applications. The EMWin Users Guide contains further information about the memory requirements. Next, we add the code to output the string Hello World to the LCD display. Again, user code templates are available for the graphics component. We choose the EMWin GUI thread for single task execution, where one task is calling the EMWin functions. This is sufficient for most applications and has a lower memory footprint. The selection adds the file GUI-singlethread.c, which contains an init function and the related task function called GUI-thread. Here we add the code to output Hello World. Since we added a GUI thread, we need to reflect this in the RTOS configuration file rtx-conf-cm.c. The GUI thread needs a user-provided stack with 2048 bytes. We therefore increase the number of threads with the user-provided stack size to 2 and the total stack size to 4096 bytes. We're almost done, and you just need to call the init GUI thread function inside main. Then compile and flash the project. To verify the new application code, enter the debugger and set breakpoints to the init and GUI thread function. We start the program execution, which is stopped when a breakpoint is reached. You may single step the code or just continue with the execution. Finally, on the display, we see the string Hello World.